This video is about the principle of mathematical induction. Here is the definition. Let P sub n be a statement about natural number n. Then P of n is true for all natural number n, if and only if P sub 1 is true for every natural number k. If P sub k is true, then P sub k plus 1 is true. If you want to use the principle of mathematical induction to prove, first step, make sure the statement is true for n equals 1. Second step, assume the statement is true for n equals k. Then you prove the statement is true for n equals k plus 1. Then the statement is true for all natural number n. If it's not a summation statement, here's the step. We will working on a sub k plus 1 on the left side. On the right side, we're working on u sub k plus 1. Then you still need to do the cap. First of all, check n equals 1 true. Then assume n equals k true. Then you need to prove n equals k plus 1 true. For number 13, you could say this is not a summation statement. Therefore, we're working on a sub k plus 1. That is change every single n into k plus 1. So we get 3 times k plus 1 minus 1. We get 2 to the 3k plus 3 power minus 1. We don't have expressions on the right side, so we don't have to do u sub k plus 1. Then we go to cap steps. First of all, check n equals 1 true. So we get the 2 to the 3 times 1's power minus 1 equals 7. It's true, 7 can be divided by 7. So for the second step, assume n equals k true, which means 2 to the 3k's power minus 1 is divided by 7. Now we prove n equals k plus 1 true. When n equals k plus 1, we already got this expression. So we get 2 to the 3k plus 3 minus 1. We want to prove this expression is divided by 7. We have to use this information. 2 to the 3k minus 1 is divided by 7. Therefore, you will create 2 to the 3k minus 1 first. Then we get 2 to the 3k times 2 to the third power minus 1 equals 8 times 2 to the 3k minus 1. In your mind, you need to know you have to create 2 to the 3k minus 1. Therefore, you can do minus 8 plus 8. So that you can take 8 outside. Then create 2 to the 3k minus 1. That's how I think. So I'll get the 8, 2 to the 3k minus 1. Then combine like terms. Negative 1 plus 8, that's plus 7. For this statement, we know 2 to the 3k minus 1 is divided by 7, which means 8 times 2 to the 3k minus 1 is divided by 7. Also, 7 is divided by 7. Therefore, we can say 2 to the 3k plus 3 minus 1 is divided by 7. Then we finish proving. In conclusion, the statement is true for all natural numbers. Number 14. We still work out a sub k plus 1. Every single n changing to k plus 1. Step 1, check n equals 1 true. We got 5 to the first power minus 2 to the first power equals 3. 3 can be divided by 3, so obvious. That means when n equals 1, the statement is true. Assume n equals k true. Look at the statement. I change every single n into k. Therefore, I got 5 to the k's power minus 2 to the k's power is divided by 3. Then we need to prove a sub k plus 1 is divided by 3. And we know a sub k plus 1 equals 5k plus 1 minus 2k plus 1. You have to make this statement into this one. Therefore, I will create 5 to the k's power times 5 to the first power minus 2 to the k's power times 2 to the first power. For this 5, you will change into 2 plus 3 minus 2 to the k's power times 2. Then you do distributive property. You will get 2 times 5 to the k's power plus 3 times 5 to the k's power minus 2 times 2 to the k's power. Then common factor is 2. Therefore, I take 2 outside. 5 to the k's power minus 2 to the k's power plus 3 times 5 to the k's power. We know this one can be divided by 3. This expression can be divided by 3 because 3 is a factor. In other words, a sub k plus 1 equals 5 to the k plus 1's power minus 2 to the k plus 1 is divided by 3. Then we can see that the statement is true for all natural numbers. For number 16, we want to prove n factorial greater than 4 to the n's power when n greater than equal to 9. Left side, we assume this is a sub n. On the right side, we assume it's u sub n. First of all, we will work out a sub k plus 1. That is k plus 1 factorial. And u sub k plus 1, that is 4 to the k plus 1's power. Now we go to cap steps. First of all, we check n equals 9 true. You have to look at the domain for this n. They said n greater than equal to 9. So we check the lowest number, that's 9. We will get 9 factorial on the left side equals. Then we work out 4 to the 9th power on the right side. We got the answer from graphing calculator. we could say that 9 factorial greater than 4 to the 9th power, which means n equals 9, the statement is true. Then assume n equals k true, which means k factorial greater than 4 to the kth power. Then we need to prove n equals k plus 1. Means k plus 1 factorial. We need to prove k plus 1 factorial greater than 4 to the k plus 1's power. Therefore, k plus 1 factorial, we can write down k factorial times k plus 1. Since k factorial, according to the assumption, k factorial greater than 4 to the kth power, therefore it's greater than 4 to the kth power times k plus 1. We know k plus 1 when k greater than equal to 9, k plus 1 greater than 4. Therefore, I could say it's greater than 4 to the kth power times 4 to the first power. That is 4 to the k plus 1's power. So we finish proving k plus 1 factorial greater than 4 to the k plus 1's power. So n factorial greater than 4 to the nth power for n greater than equal to 9. Now let's go to number 18. We want to prove 9n less than 3 to the nth power for n greater than equal to 4. Assume this is a sub n and a right side, that's u sub n. So we work out a sub k plus 1 equals 9 times k plus 1, means 9k plus 9. U sub k plus 1 equals 3 to the k plus 1's power. We go to cap steps. Check n equals 4 true for the statement. On the left side, we got the 9 times 4 equals to 36. Right side, 3 to the 4th power equals 81. Therefore, 9 to the 4th power less than 3 to the 4th power is true. Second step, assume n equals k true, which means 9k less than 3 to the kth power. Now, third step, we need to prove n equals k plus 1 true. A sub k plus 1, that equals 9k plus 9. We know 9k less than 3 to the kth power, so I can write down it's less than 3 to the kth power plus 9. We want to prove a sub k plus 1 less than 3 to the k plus 1's power. It's hard to think 3 to the kth power plus 9 less than 3 to the k plus 1's power. This is how you think. I will do 3k plus 9 less than 3 to the k plus 1. Then you need to subtract 3 to the kth power both sides. You got the 9 less than 3k times 3 to the 1st power minus 3 kth power. Then for right side, I can get the 3k times 3 minus 1, which means 3 k's power times 2. Basically, we just need to check, is it 9 less than 3k times 2? When k is greater than or equal to 4. Definitely it's true. Therefore, you will change 9 into 3k times 2. So I change into 3 to the k's power plus 3k times 2. Then you organize this. You will get the 3k's power. Take outside 1 plus 2. You will get the 3k times 3. That is 3 to the k plus 1's power. Sometimes you have to do this step to figure out how to replace the number. So we can draw a conclusion. 9n less than 3n's power for n greater than or equal to 4. For number 20, assume a sub n equals 2 to the n's power, and u sub n equals 10n plus 7. Therefore, a sub k plus 1 equals 2 to the k plus 1's power. U sub k plus 1 equals 10 times k plus 1 plus 7. Simplify, you will get the 10k plus 17. Now we go to use cap to do the mass induction proof. First step, check n equals 10 is true. On the left side, we got the 2 to the 10's power. Right side, we got the 10 times 10 plus 7. This one equals 107. 2 to the 10's power is 1024. Therefore, 2 to the 10's power greater than 10 times 10 plus 7, which means n equals 10 is true. Now we assume n equals k true, which means 2 to the k's power greater than 10k plus 7. Now we want to prove n equals k plus 1 true. We know a sub k plus 1 on the left side, that is 2 to the k plus 1's power. I can write down 2 to the k's power times 2 to the first power. 2 to the k's power, that's greater than 10k plus 7. So I can write down it's greater than 10k plus 7. Then times 2. We do distributive property. We got 20k plus 14. We want to prove a sub k plus 1 greater than 10k plus 17. Therefore, I will create the 10k plus 17 first, and then plus 10k minus 3. Because 10k minus 3 is greater than 0. Therefore, 10k plus 17 plus 10k minus 3 is greater than 10k plus 17. In other words, we got the 2 to the k plus 1 greater than 10k plus 17. So 2 to the nth power greater than 10n plus 17 for n greater than equal to 10. Now go to number 22. A sub n equals this, and u sub n equals this one. A sub k plus 1 equals 1.5 to the k plus 1's power. U sub k plus 1 equals 10 plus 0.5 times k plus 1. So we combine like terms, you will get 0.5k plus 10.5. Then we go to cap steps. Check n equals 7 true. Left side, we got the 1.5 to the 7th power equals. It will be 17 point something. 10 plus 0.5 times 7 equals 13.5. Definitely 1.5 to the 7th power greater than 10 plus 0.5 times 7, which means when n equals 7, the statement is true. Now we assume n equals k true, which means 1.5 to the k's power greater than 10 plus 0.5 k. Then third step, we need to prove n equals k plus 1 true. Therefore, for a sub k plus 1 equals 1.5 to the k plus 1's power, I can write down 1.5k times 1.5, which means greater than, using this statement, 1.5k greater than 10 plus 0.5k. 10 plus 0.5k. Then multiply by 1.5. Then we do distributive property. We got 15 plus 0.75k. We want to prove 15 plus 0.75k greater than 0.5k plus 10.5. So we will create that 0.5k plus 10.5. Then you need to plus 0.25k plus 4.5. Since this one greater than 0, therefore it's greater than 0.5k plus 10.5, which means we prove 1.5 to the k plus 1's power greater than 0.5k plus 10.5. So we can draw a conclusion that 1.5 to the nth power greater than 10 plus 0.5n for n greater than equal to 7.